Hi, I'm Fred. I'm here to present my final project, Light Field Photography in the Wild. So the motivation for the final project is that dedicated planoptic cameras usually have limitations. So they're usually high in cost, and in the case of the LiTro camera, it has limited spatial resolution, and it has a small baseline. Or you can also try to use a camera array, but that would make it also prohibitively expensive and also large in size. It's going to be something you cannot carry around. So the question is, can we capture a light field by moving around a single camera? Because the intuition is that if you just move around a single camera, it will be equivalent to having an array of cameras, right? And it will also give you added benefits of having a high spatial resolution compared to the LiTro planoptic camera. And also, modern cameras are able to shoot videos with high dynamic range. So you are expected to be able to get a really good high dynamic range footage. So not quite. We still need to localize every frame, so you know where the camera is located when it records every frame. And this problem is usually referred to as a post estimation, which means you're trying to find the rotation and translation at every frame, at every timestamp the camera is capturing a frame. And there are general two approaches. The first one is structure from motion, where we obtain camera poses with an algorithm for seeking pixel correspondences between images. And the second one is based on IMU sensors, which usually include a gyroscope and accelerometer, which you can combine to integrate to get position information about the camera. So my camera also has an IMU built into it. As a result, I tested the IMU-based camera pose estimation in addition to the structure from motion camera pose estimation, which requires no special hardware. I recorded my first dataset, which is an indoor environment, which is just me moving the camera in a straight horizontal line. And I tried to compute the camera poses with the IMU data, and they proved to be inaccurate. You can see on the image that the spacing between the dots keeps getting larger, indicating it is estimated the camera is accelerating, whereas in this video the camera just moves at a constant speed. So the IMU data based camera pose estimation is inaccurate. Next, I tried to use the structure from motion software, which is I used the open source software CalMap to estimate the camera poses, and actually turned out to be really good. You can see that in this screenshot, the cameras are estimated to lie roughly on a horizontal line, just as you would expect to see from the video. So I next went on to capture a more complex scene, where I'm in an outdoor environment and I moved my camera in a zigzag pattern, so the aperture is no longer a straight line, but a plane. By running SFM, I get that the camera poses are again very accurate. They show that the camera is moving as in a zigzag pattern within a rectangle. And with all these accurate camera poses, I'm able to form a good light field image. And then I also made a graphical user interface that allows the user to refocus, change the exposure, and change the aperture size to render the light field image, which I will demo right now. So here, what you can see is the rendered light field image, and I can change the focus so that it focuses on, for example, the chair in the foreground, and I can increase the aperture size so you get more focus blur or shallower depth of field. And then let's say if you wanted to get more details in the background in the sky, you can lower the exposure of the scene to get highlight details. And that's it for the demo. As a conclusion, light field photography in the wild is entirely feasible. We don't need any special hardware, and you can also get a really large synthetic aperture by moving the camera around freely in physical space. But you would need a steady hand because you need to point the camera roughly in the same direction and also move it in a plane. And also the entire scene needs to be static.